So for this is the M4 final hackathon, and so how we do to improve the performance of the model? So read the data first, and for the model selection, I use the boosting instead of using the basic model like logistic regression. I select the boost, which is the gradient boosting algorithm optimized for categorical features. So this provides several advantages: native handling of categorical variables like no one hot encoding needed, and better handling of complex nonlinear relation, strong regularization to reduce overfitting, high performance on the tabular datasets. Because of the datasets contains categorical features, CatBoost was particularly appropriate, and hyperparameter tooling. I carefully to keep hyperparameters to balance bias and variance. Iterations 1800s, learning rate 0.025, depth 7, leave reg 5. A smaller learning rate improves regularization, which deeper tree allow capture linear patterns. I also use the early stop for uh, 120. Um, this prevents the overfitting by stopping the training when the validation performance stop improving. So stratifies cross-validation instead of rely on single train validation split. I use the stratify folds, three folds, and this ensures the balanced class distribution in every fold, more stable performance estimates, reduce the risk of a lucky split. I evaluate the performance using ROC and AUC, um, which is more appropriate than accuracy for imbalanced datasets. Um, the full training after validation. Uh, so after validating the performance through the cross-validation, I retrain the model on the full datasets before generating final test prediction. So this ensures the model use all the available information. And For so how do I assess and improve the model fit? I evaluate the model fit in three key ways. Out of fold AUC during the cross validation, I store out of fold prediction. Um, and for the and also using the complete computing the overall autofill AUC. This provides unbiased estimate of real-world performance, learning curve analysis to analyze the bias versus the variance behaviors. I build a learning curve to train the fraction 20%, 60%, and 100%. For each fraction, I run three folds cross-validation and measure ROCs, subtract the AUC. This helps me to understand whether the model benefits from more data, whether it's underfitting or overfitting, and whether the performance stabilizes. If the curve continue to rising at 100%, okay, it may suggest more data could further improve the performance. If plateaus, the model may be capacity limited. This is strong identity. This could be a strong um, prediction for the model diagnosis. So if early stop to prevent overfitting, use like the early stop rounds I did, um, that's gonna ensure the model stop when the validation performance stop improving, and this reduce overfitting and improve generalization. So to summarize everything, what I did is I select the high performance boost model, which is the CatBoost. I threw the hyperparameters to balance the biases and variance. I use the stratified crossing validation to obtain the robust performance estimates. Also, evaluate the model generalization, use autofold AUC, and build a learning curve to diagnose the model behavior. Apply the early stop to prevent the overfitting. So finally, to train the full data set to maximize the predictive power.